This is our first video for Unit 6 on energy, and this is going to be on work and power. It's probably a good idea if you don't have something to take notes for you to pause right now and grab a pen and something to write with. Ready? Let's begin. At the end of this video, you should be able to explain what is meant by work and be able to identify when work is being done on an object, because work means something else in physics. You should be able to calculate the amount of work being done using the formula that I'll give to you. You should be able to explain what's meant by power in physics, and also calculate the amount of power using the formula for power. Finally, you should be able to explain the relationship between work and energy. Let's get started. A good place to start would be with a definition of work. So work happens when a force acts on an object, and then the object moves. And that object has to move in the direction of force. Now that we have a definition under our belt, let's check out some examples. Here's an example where a man is applying a force to a shopping cart. So the force is going this way, and the shopping cart is moving that way. So there's a force acting on the object, and the object is moving in the direction of the force. Here's another example with a man lifting a box. The force is being applied against gravity, and the box, when it's being lifted, is going to be moved in the direction of that force. Now it's important to define what is doing work on what. So in this case, the man is doing work on the cart, and the man is doing work on the box. Work typically falls into two different categories. First, work going against some other force, like gravity or friction, which we saw in the case of the man moving the box, or work to change the speed of an object, that object speeding up or slowing down, which you could say is a good case in the case of the cart. Now let's check out some examples. Let's look at this guy. This weightlifter has lifted up a big pile of weights on the bar. Is he doing work? Sure, it looks like hard work. And he's had to do work on the barbell to lift it. So the actual lifting of the barbell is work, because he's applying a force, and the barbell is moving in that direction. But once he's holding it up there, he's not doing work. So, for him to lift the barbell up, that's work. For him to hold it, it's not work. And the reason it's not work for him to just hold it up there is because the barbell is not moving. So the lifting falls into that category of moving against a force. Let's look at another example. Here we have a girl moving a box with a lever. Is this work? Yes, it's work. The girl is doing work on the lever, and the lever is doing work on the box. So she's applying a force that's going this way. The lever is moving in that direction. Then the lever does work on the box by applying a force in this direction on the box, and the box moves in that direction. Here's a case of a couch potato, a potato sitting on a couch. Is it work? No, of course it's not work. There's no work being done here because nothing is moving and there's no force. Let's look at this case. Is there work? Sure, there's something moving and there's forces, but what's doing the work? Tiger Woods is doing work on the golf club, and then the club does work on the golf ball. So this is one of those where it's changing the speed of an object. Tiger Woods is changing the speed of the golf club, and then the golf club changes the speed of the golf ball. Here's a man rolling up a barrel up an inclined plane. Is it work? Is there a force acting on an object? Yes, the man is pushing the barrel. And is the barrel moving in the direction of the force? Absolutely. So the man is doing work on the barrel, and this would fall into the category of work against another force, in this case gravity. In this picture we have Merida from the Disney movie Brave, and she's pulling back the bowstring for a bow to shoot an arrow. Is work being done? Yes, there is work being done. There's a force being applied. Merida is applying a force to the string, and the string is moving in that direction. So Merida is doing work to the string, and then once she lets it go, the string is going to do work on the arrow. So this would fall into the category of working against a force in the case of pulling the string back, and then changing the speed of an object, which is the arrow, when the bowstring does work on the arrow. So when you think about work, think about not only if work is being done or not, but what's doing work on what. Now let's check out the math formula for work. Now when we go back to our word definition of work, the formula kind of shakes out of it. Our word definition was when a force acts on an object and the object moves in the direction of the force. So what we have here is work equals force times the distance. And this kind of looks like our formula for impulse, if you remember that. That was force times time. So this one isn't worried about the time, just the distance that an object moves. Now that we have the abbreviations sorted out, let's sort out the units. Remember that force is measured in newtons, and distance is measured in meters. So if you just multiply those together, that would be newtons times meters. But in this case, we're going to have a new unit for work that's newtons times meters together, and that's going to be joules. So joules is represented by a capital J, and that's how you would spell it. You're going to do some problems of this on your problem set. Another formula that we're going to be working with is that for power. Now power in physics is the rate at which work is done. And whenever you have the rate of something, it's that thing over time. So, even though work didn't have anything to do with time, just the force and the distance, when we divide work by time, then we have power. So, power is work over time. And remember what our units were for work? They're joules. Divided by time is seconds. So the units for power should be joules divided by seconds. And we have another special unit for that, and that's called watts. So our unit for power is going to be watts, and you can abbreviate watts as a capital W. So let's use this formula to see what it means if something changes power. So if you double the power of something, let's say an engine, that means that it can do twice as much work in the same amount of time, or it can do the same amount of work in half the time. So remember, power is work over time. So if you do twice as much work in the same amount of time, that's going to equal twice as much power. Or if you do the same amount of work in half the time, that's going to equal twice as much power. So those are our formulas for work and power and how they're related. Now another way that you can think about work is just a change of energy. After all, this is the unit on energy. So what work can do with energy is it can transfer energy from one object to another, or the energy can be converted from one form to another. A good example of the transfer of energy from one object to another was when Merida was pulling back that bowstring, and when she let it go, the energy from that string could be transferred to the arrow. And energy being converted from one form to another, in order to understand that, we have to understand the different forms of energy. The type of energy that we're going to be dealing mostly with in this unit is called mechanical energy. And a good definition for that is that it's energy due to position or movement. And there are two types of mechanical energy. The two types of mechanical energy are called kinetic energy, and that's the energy due to movement, or potential energy, and that's the energy due to position. Now the subject of tomorrow's video is going to be kinetic and potential energy, or the different types of energy, so we'll save some of this for tomorrow. To finish off, let's look back at the example of Tiger Woods to relate work to energy. Now remember, Tiger Woods is doing work on the golf club, and then the golf club is doing work on the golf ball. So what's happening here? What's giving Tiger Woods the energy? Well, that's Tiger Woods' muscles, and those muscles have chemical energy. So the chemical energy of Tiger Woods' muscles is converted to kinetic energy of the club, and that's how Tiger Woods does work on the club. Now when the club does work on the ball, the kinetic energy of the club is transferred to the kinetic energy of the ball. Because remember, we said that work can transfer energy, or work can convert energy from one form to another. That's it for this video.